Hi everybody. Today we are going to look into types of batteries. This falls under Unit 2 storage devices. So here we are going to discuss about types of batteries. So the course outcome for this lesson is to impart knowledge on various energy storage sources, and the Bloom's taxonomy level is applied, and the learning outcome for this lecture would be at the end of this lecture you'll be able to gain knowledge on types of batteries. We already discussed in the previous lecture about different types of cells and what is electrochemistry is all about. So electrochemistry deals with energy conversion either from electrical to chemical or chemical to electrical, and this is what is happening in two types of cells. We have electrochemical cells, either galvanic or electrolytic cell. They can also be classified as reversible or irreversible cell. A galvanic cell is the one in which the current flows and the redox reaction proceeds spontaneously because um, of the strong tendency for the chemical species involved to give and take electrons. Whereas in an electrolytic cell, it is the one in which the current is not a spontaneous current, but rather it is the result of incorporating an external power source such as battery in the circuit to drive the reaction in one direction or the other. So, in galvanic cell, chemical energy is converted into electrical energy, whereas in electrolytic cell, electrical energy is converted into chemical cell, chemical energy. So potentiometric methods involve galvanic cells and voltammetric and amperometric methods involve electrolytic cells. So we have voltaic cell, electrolytic cell. In turn, this is classified as reversible and irreversible cell. Reversible cells, it reverses the current or reverses the reaction. Auto lead storage battery, hydrogen fuel cells are the example. And irreversible cells, it cannot reverse due to different half cell reaction occurring at one or both the electrodes. Best example is dry cell, alkaline cell, mercury cell, etc. Okay, so we can classify the cells as I told you, like electrolytic cell and electrochemical cell. And here you could find some reactions. Say, for example, in ice, it melts to give liquid state of the same thing. When it is cooled, it gets back to its original position. Whereas an omelette, when egg is broken, an omelette is made once again by the application of heat. Once again we cannot remake it. Okay, so this is irreversible, whereas the first case it is reversible. That is what is happening in the case of batteries also. So we have two types of cells like reversible and irreversible cells. Okay. Daniel cell, we call it as, actually they could also be classified as secondary and primary battery. Reversible cells are secondary batteries, or we can say rechargeable batteries. Daniel cell is a very good example for reversible cell. Actually speaking, in Daniel cell, it produces 1.1 volt when it works. Okay, and there are two conditions for a cell to react or cell to behave like a reversible cell. The first condition is that we have two forces acting on it, applied force and opposing force. Both should not be equal to each other. Okay, that is the first condition. And the second condition is that the reaction should be reversible. Okay, say for example in Daniel cell, the voltage that is produced is 1.1 volt. So if 1.1 volt is given from the external EMF, nothing will happen. Whereas if any energy that is greater than 1.1 volt is given, the reverse reaction will start taking place. Say for example, when Daniel cell is working, zinc will lose electrons to produce zinc 2 plus ions, whereas copper 2 plus will gain electrons to form copper. Okay, but now if the voltage is given more than 1.1 volts, the reverse reaction will start taking place. Okay, so here two conditions will satisfy. The first condition is that the opposing and acting force will be slightly greater, okay, or they differ with each other. Second thing is that the reactions are reversible. If these two conditions are satisfied, we call them as a reversible cell. Okay, so if the external EMF is made slightly greater than 1.1 volt, the current will flow in the opposite direction. Copper will pass into the solution as copper ions, and zinc will get deposited on the zinc electrode. We also have another type of cells like irreversible cells. Best example is zinc silver cell or dry cell. Okay, here what happens is the forward reaction at anode is zinc dissolving in sulfuric acid to form zinc sulfate with the liberation of hydrogen, whereas at cathode, silver accepting two electrons to form two silver. But this reaction cannot be reversed. Okay, so even though this satisfies the first condition, the second condition cannot be satisfied, and hence this is falling under irreversible cells, otherwise we call them as primary cells. So when the two electrodes are connected, zinc dissolves with the liberation of hydrogen gas. When the external EMF slightly greater than the actual EMF of the cell is applied to it, the above reactions are not reversed because one of the product is hydrogen gas is already escaped. Such a cell which does not obey the conditions of thermodynamic reversibility is called as an irreversible cell. So we have three types of cells which are listed. The first one, zinc in sulfuric acid, zinc and copper, okay. And here it is not reversible. Second type, zinc and zinc sulfate and copper sulfate. If the, say for example, the voltage is 1.1 volt is given, nothing will happen, okay. Whereas if the external EMF is greater than 1.1 volt, the reversible reaction takes place and that will become as rechargeable battery. So, as I told you, we have two types of cells like primary batteries and secondary batteries. Primary batteries are irreversible and secondary batteries are reversible. Okay. The common flashlight battery are those which are used once and then replaced. The chemical reactions that supply current in them are irreversible, so they are use and throw. Whereas secondary batteries could be recharged again and again and it could be reused because they use reversible chemical reactions. So here are some of the differences between primary batteries and secondary batteries. Like in the case of primary batteries, the cell reaction is irreversible, whereas secondary batteries, the cell reaction is reversible. And the primary batteries must be discarded after use, only one time use, whereas the secondary batteries may be recharged and it could be used again and again. Okay, primary batteries have relatively short shelf life, whereas secondary batteries have long shelf life. The function only as galvanic cell, whereas secondary batteries will behave both like galvanic cell and as well as like electrolytic cell. When they're working, they behave like galvanic cell, and when they're charged, they behave like electrolytic cell. And primary batteries cannot be used as storage devices, whereas secondary batteries could be used as a storage device. Example, solar or thermal energy. Primary batteries cannot be recharged, whereas secondary batteries can be recharged. And some of the example is like lithium manganese dioxide battery, lead acid storage battery, NiCad battery, and example for primary battery is dry cell. Okay, so this is dry cell and a secondary battery. We have given an example over here. So here both the reaction will take place, charging and discharging, whereas this falls under just use and throw. Okay, this is lithium ion battery. To begin with, it has 100% of energy. When it is used, the percentage is getting reduced to 50 and 25. When it reaches 20%, it has to be recharged. So the learning outcome is achieved. The students were able to gain the knowledge on types of batteries. Thank you.